Good morning, everyone, or good afternoon to you, wherever you might be. Uh, Welcome to this talk as part of the PyCon 2020 Sweden conference. Today, we have with us our esteemed guest, Kalyan Prasad, who is going to give us a presentation about using time series with Pandas. Yeah. Kalyan is a self-taught data scientist, something he explores beyond spreadsheets, and holds a master's degree in finance. He has transitioned his career from non-tech to tech staff. So I will leave the floor to Kalyan to briefly introduce himself, and then we continue with the presentation. Kalyan, over to you.
Thank you, Abdul. So you guys see my screen, right? Okay.
Yes.
So welcome. So yeah. So hi everyone. It's really incredible and such an honor to be given the stage to speak to you, all of you here today in PyCon Sweden. So my name is Kalyan Prasad. I'm a self-taught data scientist, as mentioned, and also analyst manager. And I also love involving in tech communities and try to help communities as possible as I can do. So I'm currently a core member of Hyderabad Python user group, where we promote Python and other open source softwares. And I'm also part of a PyConf Hyderabad organizing member. So PyConf Hyderabad, which is also happening in the month of December. So in case if you want to check out, you can check out our website for more details. Okay. So here is the actual outline of the talk. So we'll start with what time series it is, and we'll also discuss some key elements of time series, and then we'll talk about the resampling, and we'll also show you how to resample with pandas, and then followed by we'll also show you the resampling and some other operations with the power of Python and pandas. So if you are not already aware of this concept, then you are really in for a treat. If you are, I believe a short recap won't hurt. Okay, so some caveats to get started. So time series analysis is particularly complex and controversial field. In my opinion, there are no magic recipes. I think more or still with any kind of analysis, you have to really careful with your assumptions. I'll give some framework as we move ahead, but you really need to read more when you want to do a real analysis. Let's say if you want to do a time series analysis at your work or your academic level to make a real conclusions or a real arguments, this is not going to get you there in my 30 or 45 minutes of talk. So for that reason, domain knowledge is really important. Let's say if you are trying to figure out if you are trying to figure out how your process is working over time, the more content you have, the more understanding of your system, the better inform your models are, or the better your models perform. So I believe nobody can fix a time series issues without a domain knowledge. So what is time series? So there are many definitions of a time series, out of which indicate the same meaning in a different way. A traditional straightforward definition is sequential data order matters. So a time series is a sequence of observations taken sequentially in time. So now when we are forecasting a time series data, the main aim is to estimate how sequence of observation will perform in future. So observations are typically collected at regular intervals, such as every week, every day, every month, or monthly, yearly, etc. So, for example, if you are talking about weather data, we may receive weather updates for every hour or every 10 minutes. Or if you are talking something about IoT sensors or something like that, where you receive the data continuously. So, depending upon the source of the generation, you may have different frequencies at which data is collected. Advancement in machine learning have increased the value of time series data because there are so many prediction problems that involve time component. Companies apply machine learning to time series data to make informed business decisions or do forecasting, compare seasonal or cyclic trends. So, time series forecasting helps us to predict the future values of a critical field which has a potential business value in the industry. For example, let's take predicting the health condition of a person or predicting the result of a sport. So, it is everywhere. I'll justify this statement with a couple of examples in my next slide. So here are some of the examples of a time series data, monthly sales data. So if you are a retail company, you may have your monthly sales data or quarterly or annually revenue. Let's say if your company has listed where you publish your quarterly or annually revenue. Likewise, hourly weather data, wind speed data. If your IoT sensor installed in all industrial device that generates continuously data. Let's say stock prices, you see the fluctuation of prices changing over a period of time. Energy forecasting. So energy forecasting is something where we are trying to understand the demand for electricity and accordingly manage our production. So if we are overproducing, we may want to sell it in a supermarket. So these are some of the typical use cases on time series. So when we are talking about a time series, the first thing is to understand the key elements, then we can compare it. So the data can have seasonality, the data can have trends, the data can have cyclic, the data may also have a random or irregular variations, or the data can be stationary. So what I'll do is I'll quickly touch upon all these concepts, but again, I'm not going into much detail about it because which goes beyond the scope of this talk. So seasonality. So seasonality pattern occurs when a time series is affected by a regular occurring pattern, such as the quarter of the year, the month, or the week, or the day. For example, during a holiday period, during a holiday season, where you see Amazon and Walmart has a huge sales that generate some seasonality in data. So seasonality pattern is always a fixed time period. Trends. So a trend exists when there is a long-term increase or decrease in the data. So it does not have to be linear. Trend will also often refer as a changing direction, where we may see it might go from an increasing trend to a decreasing trend. Let's say take the scenario of a COVID, where you see some companies have a huge revenue. For them, you'll see an increasing trend because of this lockdown. We may see that restaurants and outlets were closed. For those, you will see a decreasing trend. Cyclic behavior. So a cyclic behavior occurs when the data exhibits rise and falls that are not a fixed frequency. So these fluctuations are usually happen due to economic condition and are often related to business cycle. So the fluctuations of the frequency of these fluctuations are usually at least two periods. And one of the important point which I would like to tell you here is most of the time people get confused with cyclic behavior with seasonal behavior. But in reality, they are quite really different. If frequency are of not fixed period, then it is a cyclic behavior. If fluctuations are not changing and are associated with some aspect of a calendar, then it is a seasonal pattern. And in most time series data, we have a seasonality, cyclic, and trends. So when forecasting a model, it is important to understand the time series patterns in the data and then choose a model which is able to capture the patterns properly. So random or irregular variations. So random variations are the fluctuation which are a result of unforeseen and unpredictable forces. So these forces will happen in an absolutely random or erratic manner, and which does not have any defined pattern. For example, these fluctuations may happen due to floods, earthquakes, strikes, etc. Stationary data. So stationary pattern is something like where we see where our mean is constant, standard deviation is constant, and we don't see any some seasonality or a trend in our data. So first two are really important when we are looking at stationary data. For seasonality or trend, so we may use certain techniques that we can make our data stationary if it is a non-stationary. Okay, there. So here are some of the examples of the concept which I have discussed earlier. So if you see here the monthly, so the US house sales price on top left shows a strong seasonality as well as some strong cyclic behavior with a period of about 6 to 10 years. So if you see here, there is no apparent trend in the data over a period of time. On the right side, if you look at US Treasury bill contracts, it shows the results from Chicago market for 100 consecutive trading days. So here there is no seasonality, but obviously a downward trend. So possibly, if we had a much longer series here, we could see that the downward trend is actually of a long cycle. But however, here we are viewing only for 100 days, so it seems to be a trend. So if you look at Australian quarterly electricity production on at bottom left, it shows a strong increasing trend with some strong seasonality as well. So there is no evidence of a cyclic pattern behavior in this case. And lastly, if you look at daily changes in Google clothing stock price, it shows that there is no seasonality, there is no trends, there is no there is no cyclic behavior as well. So there are random fluctuations which does not appear to be very predictable and no strong pattern that would really help with developing a forecasting model. So there we comes our main topic, resampling. So what is resampling? So resampling is to convert our time series data into different frequencies. So depending upon our requirement, so we can convert our time series data to different frequencies for our analysis. So there are two types of resampling technique, which is called upsampling and downsampling. So if you are increasing the frequency of samples from minutes to seconds, then it is a upsampling. If, for example, if you are decreasing the frequency of samples from days to months, then it is a downsampling. So next, how how to resample in pandas. Now you might be wondering why I actually need to resample my data. Why not actually work on as it is? So there are two important reasons which we may be interested in resampling our time series data. One is problem framing, and other one is feature engineering. So on a problem framing side, resampling may be required if your data is not available at the same frequency you want to make predictions. For example, let's say, imagine that you have a 20 years of historical prices of S&P 500 index data. Your boss has requested us to present the data in monthly frequency instead of daily. This is where resampling comes in handy. So we can simply convert our daily frequency data into monthly frequency and develop our model. On a feature engineering side, resampling can also be used to provide an additional structure or insight into the direction of learning problems for a supervised learning models. So a feature engineering perspective may use observation and summarize of observations from both time scales and more in developing a model. So why Pandas? So Pandas is a savior because it was created by Wes McKinney to find explicit and flexible tool to work on a financial data. So therefore, it is a very good choice to work on time series data. And resampling a time series in Pandas is very easy. So I'll be showing you quickly how it is very easy in the next couple of minutes. And the best part of Pandas is it also offers multiple resampling frequencies that we can select in order to resample our data series. Okay, so here are some of the common frequency methods which I have listed in my slide, but actually the list is quite huge, so I was not able to include all the frequency methods in my slide. But again, you can find everything on the Pandas official documentation. Uh, so one thing I would like to tell you is it's not possible to remember each and every frequency method. So you can so you can keep it somewhere close to you. So whenever if you require, you can quickly can do proceed with your analysis. Now there comes our resampling and operation with Python and Pandas. So what we can do is now with the power of Python and Pandas, so how we can use different resample techniques and we'll perform different resample or different time series operations. So I'll quickly show you the steps how we can do that. So what we can do is we'll quickly load our time series data into a Pandas data frame, and then we'll convert our data column into a Pandas data types, and then we'll choose the resampling frequency method and apply frequency, and then apply to our resample method. And we'll also perform certain time series operations like a rolling, moving average, and shifting. So what you'll be seeing all these things practically in my Jupyter notebook, which I have already created. So, so here is the code of my notebook. So basically the goal of this notebook is to show you a different resampling techniques and also some time series, important time series operation on stock related daily historical prices with the power of Python and Pandas. So as usual, we'll import necessary suspects. So we have imported pandas, request matplotlib, seaborn. Okay, now we'll extract the data. So we'll be using, as I mentioned, we'll be using the NASDAQ index as an example. So we retrieve all the financial data from the financial modeling prep API, which is the source for our data. So in our case, we'll be retrieving all the NASDAQ historical prices data in the last few years. So in order to extract the data, we need to have an API key. So what I've done is, so with the request of get, I have passed my URL, and I have also passed an argument called NDX so that it will generate my NASDAQ historical prices. And I have also used the F string. So F string in order to pass the value to the variables in the URL, so once I execute, so I'll get a huge list containing the historical prices of each day of the NASDAQ. So there you see the huge list of the historical prices of the Nasdaq. Next, what I have done is I have picked my historical key here, and now we can see we can see the historical prices of a Nasdaq over time. So once I execute this, you will get a list. Each element of this list contains the daily prices of a Nasdaq starting from the recent one. If you see here the date, which is the 12 to 11/20, which is yesterday's price. Okay, in order to transform this to a pandas data frame, so I want to get rid of this list. So for better data manipulation, what I want to do is I will create a loop to go through the each element in that list. So then I'll add that to dictionary, because with that I can convert that into pandas data frame with the dictionary method. So here, if you see here, I have created the loop. So I want to keep my date, and my dictionary acts as a key, and the item will have all this information. So what we are doing now here is we are we are creating a nested dictionary contains the daily information of a Nasdaq of that particular day. So if you see here, the date is the key, and we have the respective information of that particular date. Awesome. Now I'm converting that into a data frame with the help of a dict method. I'm passing here my dictionary. Now you see here we have a pandas data frame for the Nasdaq time series. Okay, so until now we managed to create a pandas data frame. So now we are ready to apply the resample method and convert our prices into desired frequencies. Before that, I want to do some data preparation for our data frame. So if you look at our data frame info, I can see that date has a non-null object, which means indicates that it is a string. So I just want my date column to be a date time object. So there are possibly many ways to do that. So the simplest way, which is I have done, is my data frame is equal to where I am passing my date time function, and I'm also passing here my series value. So what here is, this will reformat the date column into a date time object. So once I execute this now, you can see now that date is a datetime object. So for any sort of a resampling, we need to have a datetime index. So if you see here, and for that I also done, what I've done is I have also set my date as an index. Now we can see my date as an index followed by other column. So you can see the date as my index. So now we are good to proceed with the resampling. So as I mentioned, so it is very easy to do resampling pandas, and yeah, by using a very minimal code here. So you can see in the below, you will see we are performing a different resampling techniques on our data frame. So it is very easy. What I have done is I have created a variable, it is monthly prices, where I have selected the adjusted close price column, which is the latest closing price. What I'm doing is by using a resampling function where I'm passing my frequency as monthly. So, and also for any sort of resampling, there is need of an aggregation method to give some sort of result. So what I'm doing here I'm passing my aggregation function as mean. So once I execute that, you can see the monthly frequency prices. You can see my monthly adjusted close prices of over a month. Likewise, I also did for yearly. So if you see at etf.resample, you can see the prices of a yearly, where you see the 2015 price as 4650, but for the 2020 it is somewhere or not, where you see there is an increase in prices. Likewise, you can also do a business quarter, where it will give you the business quarter information for every quarter, how your prices are uh, have a aggregate value. so so there are a lot of frequency methods. So as I mentioned, so depending upon your requirement, you can select your frequency methods and do your analysis. Now you might be wondering, is there any way to do a resampling on multiple columns? Yes, we can do a resampling on our entire data frame. So what I mean by that is, so instead of a single series, what I'm doing is here I'm resampling weekly on my data frame by selecting a multiple columns called adjusted close, high, max, min, and volume. So this can be done with the help of aggregate method. So the aggregate method agrees acts as a map to the columns, and the aggregate function will perform to that column what function, what aggregation we want to do that column. So if you see here, for adjusted close, I want to have a mean. For high column, I want to have a max value. For low column, I want to have a min value. For a volume, I want to have a sum. So once I execute this, you can see how my adjusted close prices have a average value, how my high value, how my high column have a high value over this particular date, how my price are low at that particular date, how much volume are traded on that particular will give you some. So this is really great, right? So what we have done so far, we looked at it. We have looked at different resampling techniques of monthly, quarterly, annually, all of that with a single line of Python code, which is really cool, right? And there is also a possibility to create a custom function which they can use with a resampling. So what I mean by that is, so I want to create a custom function. I want to return the first instance period of that particular period, first instance. So see what I have done is here I have created my function as a first day, and I'm passing an entry. So returning an entry with an index value which is a zero, which is the first index entry of that particular period. Now what I'm doing is I'm taking my data frame and resampling it by year and applying my own kind of a time series function, which is the first day. Now this will return the first instance value of that particular period. But again, so in to build a so most of the time this is not commonly used in building a real world applications, because there are so many built-in functions are available. But just keep in mind that this is also a possible way. Okay, now we'll see the visualizations with resampling. So how effectively we can do that. So what I have done is I have selected my data frame and selected my adjusted close column, and I have plotted here. So now you see how my prices are how my daily prices are broke down into a different period of different period of years. Likewise, you can also see my volume, how my volume are traded over a period. So with this just only a single line of code. So we can, there is also a possible way to do a resampling with plotting. So what I've done is I've selected a just a closed column and resampled it by year, and added my aggregate method. Now I'm plotting. Here I have given as a bar chart. So now you can see how my adjusted closest prices have a fluctuation over years. So here I have given a different color. So you'll see how year on year how my prices are changes. Likewise, I have also selected the resampling with monthly, and I have also plotted. But what I have done is here I have selected a period called from 2020 January to November 2020. If you see how my prices of my adjusted close prices of a monthly have a increasing, how at a point of time they are decreasing, how at a point of time they are increasing. You can clearly see that. Likewise, you can also see quarterly plotting for a low prices, how my prices are low over a period of quarter, I mean particular year, how they are increasing at a particular year, at particular quarter. So this is also another example how our high prices are over a period of time. So 2016, how my prices, how this shows a clear scatter plot. So most of the time, these visualizations are really helpful to identify the time series pattern, which will give you a picture, and then based on that, we can do apply our necessary forecasting models. So the visualizations are always helpful for data analysis part. So the next what I have is a rolling. So rolling is very useful operation for time series data. So rolling means creating a rolling window with a specified set and performing a calculations on the data. So what I've done here is I'm selected my data frame and selected as a column. I'm selecting here the 10 rows of a adjusted close price. So here I'm applying that. So based upon this 10 rows, so I'm applying my rolling function here, where I'm giving the size is 5. So if so, now the aggregation will happen from the fifth row. If you see here, the 13, 12, 2015 is the main value for the first 5 aggregation. If you see 2012 2015, the mean value is for the second to sixth of the original data. So rolling really plays important when doing a time series forecasting. And next we have is called the moving averages. So moving averages are simply in most of the time series forecasting or time series analysis, moving averages are really helpful to smoothen our curve. So moving averages are really helpful to analyze our time series data by performing average calculation on subset of our original data. Adjusted closest prices are changing over time. So what I've done is I've selected my data frame, then I have given my function rolling, where I am giving weekly, because I want to use weekly data to create a rolling average here. So it will generate average values based on the weekly here. So once I plot here, so if you see here, the green line is the moving average line, and the blue line is the adjusted close period over time. So here the curve might look a bit rough here. So what I've done here is I want to use same function, same column to create a moving average for monthly. So here I've selected my window size as 30. Now if I plot this, you see how my curve is so smooth, and so it is really important for the people who are investing or making prediction on the moment of the stock market, because this curve will really helpful for them to build their own strategies, trading strategies, and make wise decisions. And then what we have is called shifting time data. So time series data analysis may require to shift data points to make a comparison. So it all depends upon our task. We can shift the data points or the index. So it purely depends upon the case to case how the shifting works actually. So here is the example. So here I am shifting my data frame for one row up. So if you see I'm one row up, you see here my values are one row up. If I want to shift down to one row, you can use the my negative index here. So it will down. It will just down the shifting move from up to down. So depending upon your requirement, you can perform your shifting time series index analysis. So yeah, so so in case if you want to explore more about time series analysis, these are some really great books. Probably you can refer them. And That's all I have from my end. Thank you. I'm open to take questions if you have any.
Okay, thank you, Kalyan. It has been really an insightful presentation, and very fast and efficient. Yeah, just a reminder to our viewers, you can post your questions here through the chat box, and Kalyan will answer them promptly. Well, for the meantime, while we wait for questions from the audience, I have one or two questions for you.
Okay.
Yeah.
Okay.
Let's start with the most basic one. Nowadays, considering the huge opportunities in data science, machine learning, and stuff, the workforce is simply not enough to meet with the demand. So many people wonder, is it possible to be a self-taught data scientist without generally going through the conventional process of having a CS degree or a data science degree. Could you elaborate more to our viewers on this kind of pathway if you want to take it?
Yeah, sure. Okay, am I visible now?
Yeah, you are visible.
So, the question was like they don't have CS. What can you just repeat the question?
Is it possible to be a self-taught data scientist without having a conventional computer science degree or a background in data, like going through a university, having a bachelor or a master?
Cool. So firstly, I'll tell you, is it 100% possible because I'm the living proof. I don't have a traditional computer science background. I came from a commerce and finance guy. If you ask me something about, or if you ask me something like, if you, 3 years ago, to be honest, I didn't know anything about technology. As I mentioned in my intro as well, so something I explored beyond spreadsheets. So prior to my data scientist work, so I used to spend most of my work in spreadsheets. But somehow I realized that there are something we can do beyond Excel. That's how my data science journey has begun. So it is 100% possible for the people who don't have a traditional degree or a traditional computer science background. So the only thing is you need to decide for a data science. I mean, like what kind of a desired role you are looking in a data science. So the qualification really doesn't matter. So in order to step into a data science, you need to level up your data science skills. So you need to have a fixed structure of path. So which path you want to go. Like let's say if you want to be a data engineering side, so you need to concentrate something on a data engineering stuff side. Or if you want to something go on a core ML engineer side, you need to target something on focusing much more on a ML algorithm, a lot of maths, a lot of stat stuff. So depending upon your interest of a choice, which side of a career you want to go, so you need to figure out your path. So 100% there is I can say it is 100% possible for us being a self-taught data scientist. It's not only by me. There are so many people who have made a transition to data science careers without not having a computer science degree background.
Okay. We also have one question from the audience from Nerf. Hi, Kalyan. Thanks for the talk. The question reads, can you see it on the screen? I'm displaying it. Would you also recommend Pandas for resampling big data in a time-critical manner? Then the second part of the question is, if not, is there any way to increase the performance?
Personally, I have not dealt with, not deal with a huge big data. Maybe if not with Pandas, probably Apache Spark would definitely help for time series, I believe. I never tried it, but it's my assumption.
Okay. So that's I assume the second answer to the second question. If not, is there any way to increase performance? So you recommend Apache, but you've not personally tried it.
Yeah. So yeah, Apache Spark maybe is a way to increase the performance, I believe.
Okay. Yeah. So as we wait for more questions from our viewers, I also have one hot question for you, kind of trivial, but it's worth answering. Assuming one comes from a non-technical background, what challenges will they face while learning programming? You can use yourself to answer this question.
So sure. So while I was learning program 3 years ago, the biggest and personal challenge which I faced was to not asking help for people. So I was quite introvert, like I was not reaching people when I was getting confused or when I was learning, because everything was new to me when I was learning coding and all, because because I really don't know anything about coding. So when I was learning, so the thing is, I don't know the solutions for certain things, and at the same time, I also hesitated to ask people. To get the solution. So this is the biggest challenge which I personally faced. And also finding time is also really important when you are learning programming. So you need to create a certain, you need to dedicate on your time. You need to stick on your time, and you need to keep your learning consistently. You need to code regularly. That's how you can you can overcome the challenge. And at the same time, and one of the important thing which you should also keep in mind is, we should not think in a way that we should learn everything in a single go, like it's not possible to learn everything in a month, or even if you ask me 1 or 2 years, it's not possible to master everything within that. It comes with an experience. So how your experiences is, you will get to learn things, or you'll get to habituated to things. So a lot of things. So these are all challenges you need to have. So you should be focused on these.
Yeah. Uh, Logical answer. We have a question from Claudia Casconi. She says, thank you for the very interesting talk. Thank you so much, Claudia. A follow-up question. Did you also try to identify outliers and events in time series besides forecasting? That's the first part. And then the second part is, do you have any recommendation?
Outliers and events. So outliers and events in the sense, though. So I'm not sure. So if they're asking outliers, something about random fluctuations, something like that.
No. Besides forecasting, she says, did you also try to identify outliers and events in time series besides forecasting?
Maybe I'm really no outliers events in terms of besides forecasting. Okay. Yes, probably. I mean, yes, we can identify outliers, but if you ask me something on recommendation side, right? Maybe I'm not finding a right example to quote you. Maybe I'll think and I'll get back to your answer. Probably
Yeah.
I'll give you my answer in Slack, because I'm
Okay.
not finding a right example to quote you for your question.
Yeah. So let's move on to my last question, which was somehow part of your intro. Like briefly, how was the transition from being a business analyst to a data scientist?
So, so the trans. So, as I mentioned, so data was there from my first job. So, from as a research analyst, I used to play with a lot of data, a lot of financial data from my first job. So, as a business analyst, so most of my job was to gather requirement, talking to stakeholders. Most of the time is to do a lot of communicating with stakeholders and stuff, and a very minimal of a data analysis stuff. So when I realized that I just want to do a lot of analysis, dealing with real world data continuously, understanding the requirements of the stakeholders, talking with a lot of product teams and other dev teams. So 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 the data analysis stuff was very minimal when I was doing a business analyst job. So when it comes to the data scientists, so we do a lot of data analysis stuff. We play with data, we crunch the data, we wrangle the data. And we show a lot of we show the insights to stakeholders in case if we want something to be modified, and we'll go back and we'll do the modifications again. We'll use a lot of machine learning techniques. So the only transition, the reason behind for my personal transition is I'm very much passionate about data analysis stuff. So where in my previous job was very minimal. So but when I realized that I can really do beyond more of my current job, so that's how my transition has happened. And when I was transitioning to data scientist job, and one of the reason which really helped me to get into a data scientist job is my domain knowledge. So when if you are to have a solid domain knowledge, that would be really helpful if you are transiting your career in somewhere in a mid or profession.
Yeah, pretty logical. We have just few minutes left, so on a final note, I would like to ask like a general question, which could sort of be uh, mm, a, a guide or a recommendation to people who are watching and listening to this talk. Yeah, for example, now that the trend is many people transitioning into data, machine learning, and stuff by means of self-learning. What advice do you have to people who really want to pursue a career in this field but don't have like a background as a developer? Like a lot of people get scared of like they will ask themselves, I have not ever coded in my life, and some people have been coding ever since they were kids. So how can you like uh, fight this imposter syndrome? How can you like best position yourself without a software or a developer background to transition into data? Obviously, you don't need to be a master of coding in Python to be able to start data, as you mentioned earlier. You can know everything at once. Yeah. So briefly, could you like give a guidance to people out there who really want to venture
Yeah.
into data?
Firstly, I personally suggest people that don't go for very expensive courses which are available on the internet, because there are plenty of free resources you will find on the internet or in YouTube. So start with the basic level like as I mentioned. So you need to start with the basic level. So depending upon your role and your goal, so you need to figure out your path. So let's say if you want to be a data scientist, so you need to have a basic programming language. You need to have a basic understanding of statistics. You need to know certain algorithms of machine learning. And again, if you and you need to be little aware of a deep learning. It's not mandatory that you should be aware of a deep learning and all. So you need to plan your structure according. So first you need to learn coding in Python. So slowly you need to learn. So what are the basic level of stuff which I need to learn on a Python side, or in case if you are interested for other languages, let's say RA, so you need to figure out what are the things which I want to learn and so once you learn the things, so don't simply learn the things and leave out. So whatever you learn, try to put them in practically. So try to play with the data, or try to use your skills, or try to practice your skills, whatever you learn, and try to put them into a practical. So you'll find many data sets on online, or a lot of sets there are a platform called Kaggle where you can play with data. Uh, you can make your hands dirty. The more you make your hands dirty, that's how you get familiar with the concepts, and that's how you'll get a grip on your data analysis stuff or data analysis, whatever it may be. If it is a machine learning, whatever. So the more you practically play with the things, that's how you learn things. So simply reading, or no, most of the times, I also personally did initially when I was learning. I used to copy paste the answers, so I finished that and okay, there I got my answers. Okay, I'm good. But most of the people do like that. But again, so understand the context, try to understand the syntax, how to use and how to write the things. So likewise, slowly you need to improve the process.
Yeah,
But when
that's
it and
pretty
again, lastly,
logical.
when it comes to yeah.
Yeah, when it comes to what, you can go on.
Yeah, I was talking about time. I mean, if you have a kids or a family, whatever maybe, so you need to prioritize your goals and times. So everybody has their own difficulties while learning. So it's not that everybody is free or everybody is pretty busy. So so if your goal is very strong, then you will definitely make time and you stick to your learning. That's how you'll make progress.
Yeah, it's pretty sound advice. To master anything, you need to get your hands dirty. You need to learn by doing. Okay, viewers, I'm afraid to tell you that we have come to the end of this talk. For people like Claudia Casconi and co, Kalyan is active in the conference Slack channel. So the discussion will be moved there. You can post questions to him and he will answer you promptly. So once again, Kalyan, thank you so much for taking your time all the way from India to join us. It has been a really insightful and very educative talk, and we hope to see you next year during the next conference. And to the rest of our viewers, you can follow other talks. More information about the schedule for this last day is on the website. Thank you all and have a nice day.
Thank you, Abdul. Thank you for having me.
Thank you.